So another example from chapter 6.4 and logarithmic functions asks us to state the domain, the range, the x-intercepts, and the y-intercepts if they exist. So let's discuss first how to find these things. So we have the domain, and we know that this is restricted by undefined y values obtained by certain x values. So if you remember, all we have to do is, let's say we're given some log, any base, some expression in here. We just set this expression greater than 0 to find where our function is defined. And then we have our range. And this is always going to be just negative infinity to positive infinity, or all real numbers, because the log function is the inverse of the exponential function whose domain is all real numbers. Then for the x-intercept, all we need to do is set y equals 0 and solve for x. And then for the y-intercept, we set x equal to 0 and solve for y. So f of x is log base 4 of x minus 1 plus 2. So we take this to figure out our domain. So x minus 1, we're going to set that greater than 0. And we get x is greater than 1. So our domain is going to be from 1 to positive infinity. Then our range is going to be all real numbers, or negative infinity to positive infinity. Then our x-intercept is going to be obtained by setting y equals 0. So we have log base 4 of x minus 1 plus 2. We're going to set this equal to 0. And then from here, we just use simple algebra to solve for x. The first thing we want to do is get rid of that 2, so let's subtract 2 from both sides. Then we get log base 4 of x minus 1 equals negative 2. And then we can just rewrite this. So raise 4 to the negative 2 power and set that equal to x minus 1. And we know that 4 to the negative 2 is 1 over 16. And then if we add 1 to both sides, and then we get x. So x equals 17 over 16. So our x-intercept is going to be this point, 17 over 16, comma 0. And then our y-intercept we can find by setting x equal to 0. So we have log base 4 of 0 minus 1 plus 2. And then this comes out to be log base 4 of negative 1, which is undefined. So this does not have a y-intercept, and that's okay. That just means it never crosses the y-axis. So then g of x gives us the natural log of negative x minus 2. And we can find the domain by setting this, again, greater than 0. And if we divide by negative 1, that sign changes or flips. So x is less than 0. Then our domain is going to be negative infinity to 0. Range is the same. And then our x-intercept, we're going to set this whole expression equal to 0. So if we add 2 to both sides, we get natural log of negative x equals 2. And the natural log is also just the log base e. Let's rewrite it this way so that we can rewrite it again. So we have e squared equals negative x, then x equals negative e squared. And this simplifies because we know that we can calculate this out because we know that e equals 2.71 and so on. But for the sake of this, we'll just leave it as negative e squared. So this is going to be our x-intercept. Then our y-intercept we find by setting this equal to 0, setting x equal to 0. And ln of 0, again, is undefined. So this doesn't have a y-intercept. And then the last one, h of x, is 5 times ln of x minus 15. We can find the domain by setting the inside equal to 0, and we don't have to solve this time. It's just simply 0 to infinity. Range is the same, and then the x-intercept, we'll set this equal to 0. Then we get 5 ln of x equals 15. Let's divide by 5. So ln of x equals 3. So the natural log is log base e of x equals 3. We can rewrite this as such, and that's our x-intercept. So e cubed 0 is our x-intercept. And finally, our y-intercept, we're just going to set x to 0, minus 15. And then can't take the natural log of 0, so this does not exist either. And those are our answers.